In this video we will examine magnetism. We will again use electrons since it's the most simple thing to use, and a charge which is in the base of all electromagnetics. Before we start, we should say that you should have a look at the previous videos, because there is the beginning of this new theory, and if you have not visualized these videos, then you will have difficulties to follow what happens next here. In the previous videos, among other things, we gave a description of the electron and its interaction as an electrostatic field, with many characteristics associated with this. So now we will continue. See what's happened when we give some speed to this electron. So electron at a constant speed, we will see. First we will see that the Daons in front of the electron has to be compressed slightly, and you have that the speed between the Daons interaction is reduced, which gives a lower force. But at the same time, since the force is inverse proportional to the radius of the Daons, you have a strength increased of the strength of the interaction due to the reduced size, which exactly compensated the difference in relative velocity. The same thing happens behind the electron. You have an increase of the interaction force due to the difference in velocity, but at the same time the Daon becomes bigger, so its force is reduced due to the increase in size. So perfectly compensate one another. So in front and behind the Daons, you don't have any action connected to this speed. First, before we continue, we should add an equation for the signal velocity. That is the velocity an electron sends away to say, here I am. It reaches the shells around the electron delayed compared to the movement of the electron. That is to say, when a charge receives the signal that there is an electron somewhere, the electron has already moved further ahead, and this leads to a décalage, a change of perspective that you see in this figure here. And this difference you can calculate, and you get the following equation, which is important for the future. You should better understand this thing. The beta is the velocity of the electron divided by the speed of light multiplied by the order. Otherwise you have this angle, it's the theta angle is defined in the figure. Okay, if you now see the inclination of the Daons relative to the free Daons or to the electron, you will have a difference of the inclination of these Daons from shell to shell, which will result in a rotation of the electron. This comes from the already defined equations of interaction between Daons, which have given a small angle difference, in this case small angle in the transverse sense. This will push the Daons apart, and the result will be a rotation of the electron. It will be an interaction essential between the Daons connected to the electron and the free Daons further away. So of course the electron will start to rotate and not the universe. So okay, so now you have a rotation around the electron, which we can express in the following way here. As you see, it's proportional to the order, of course. The theta is the angle relative to the velocity. K is a constant. Okay, we will have a look at it. The VL velocity of the electron. Okay, We have at the same time in the direction of the velocity a sliding movement between the different shells. So also there a sliding movement that gives also another angle to the downs from shell to shell, which can be expressed in the same way as the rotational. You say a velocity of the electron divided by a constant multiplied by the order and the angle. So it's in a sinus for that. Okay. So then of course with this speed of the electron can come up to c. So if you impose velocity c, you have that this constant k must be 1, which means that the signal velocity, as it was expressed earlier, must be equal to the speed of light. So, so the rotational. You see also here that the velocity of rotation of the downs around the electron gets the same speed as this velocity following the electron in its direction of speed. So this is equally the same speed. I mean, you go ahead and you rotate with the same speed in each shell. You can take a shell and you look at it and you see that this is comparable. The speeds are identical. Okay. If you, we can also calculate the rotational energy of such a movement, and if you do that, you find that this is in the same order of size as kinetical energy. It's slightly lower, but very close to the same to the kinetic energy. It's not the same, so it's an energy that is rotational. Okay, now let's have a look at the magnetic equation. You have Biot-Savart's famous formula, that you see here. That is the force is equal to the velocity multiplied by some sort of flux or magnetic field, which we don't really know what this is still here. Then we will see a figure. We will look at this figure here. So this will give an explanation of what is the phenomena of magnetism. So you have a source electron moving, and as we have just explained, if you have a moving electron, you have a flux of downs surrounding this electron, rotating around it. And now if you put another electron with some speed close to this source electron, you will have that this flux of downs, let's say, is going down surrounding the target electron. So if we know to simplify things, we will have that this flux coming perpendicular to the velocity of the target electron, and we'll have a nice pure magnetic action. So what happens in this case, you have that you have a flux of downs coming on top of this target electron, which means that you give a rotation to the electron, target electron, so it changes its direction of flight, as you see in the figure. That means that the down flux, which the rotation of the target electron had to correspond exactly to the velocity of the external flux of downs, otherwise it will be disadapted. So here you have now the explanation. You have that this target electron moves, and then you feel the flux of downs surrounding, free downs more or less, and then it deviates. So this is the explanation for the magnetism. Now we will make some calculation on top of this. First we will imagine, we will calculate the intrinsic force. That is, let us suppose that an electron is moving straight ahead, and we stop its movement relative to the free downs, but we allow it to rotate. If you allow the electron to rotate standing still, then you will have an inclination of the downs associated with the electron, inclined like this, and you will have a force pushing on it. This can be calculated, as you see in this equation here. And you should understand that this force pushing forward the electron is tangential and not radial, so it's slightly different from the radial calculation we made earlier for the electron standing still. And it's a factor of 2, in fact. So you get this pushing forward, which is a very important equation, because it gives you another idea of the force in this electromagnetic physics. As you see here, you have something which is proportional to the velocity of the electron divided by c, and this is proportional to the velocity. The force is proportional to velocity of the electron. This is important. So this intrinsic force gives you the force of the shell divided by 3 multiplied by the velocity of the electron divided by c. It's very simple but a very powerful equation that we will look at later on. So if you now, now you have a force, intrinsic force forward. Now you apply the flux coming from up, which gives a rotation, velocity of rotation proportional to the velocity of the flux, and this makes that the target electron deviates. So to get the force of magnetism, you just multiply the inherent intrinsic force with the rotation of the electron, and you obtain directly the equation for the magnetic field, as you see here. Make attention to the fact that the relation between the speed and the velocity of light is connected with each electron separated from each other. So it's not so nice to have a formula where you put in a c square, because you don't realize what it really means, which is that it's a relative inclination between the Daons and due to the speed of light, and this should be separated from each other. So instead of having v times p, you should have v divided by c times p, which would be much more correct from physical point of view. Of course, if you take a look at the permeability, you obtain the correct value, classical, no problem about it. Okay, so this is finished. Magnetism is explained. Also, this is a book of the DAON Theory. You can find it, just write Google the DAON Theory book or something like that, and you will find this. There you have more detail about the mathematics, especially. It's difficult to present mathematics in a video. So for those of you who are interested really to follow the mathematical development, you should look at this book, and this will explain everything in great detail.